to do any type of limit that they throw at you. After today, I'm not sure if tomorrow we're going to do rates of change. Maybe, maybe not. That's like introduction to like a derivative and all that good stuff. But we're going to be doing the limit part first. All right. So now it's just a matter of practicing a whole bunch of different ones. And after today, you'll be able to do UH Quiz 2. I'll show you that one question that we were lacking. And you'll be able to do UH Quiz 5. Did you already see that on Canvas? Okay. UH Quiz 5, trig limits.
Wait, you've only done one UH so far, right?
We've only done one.
Okay, good.
All right.
So we're skipping 3 and 4 for now?
No, 3 and 4 we're going to be doing like probably next week. It's on continuity.
Yeah, but right now.
For now, yeah. All right, here we go. Ready? Example number 1, letter A. What should I, plug it in, direct substitution. Can you do direct substitution?
Yes.
Yes, plug it in immediately. So let's see, 2 minus 4 over 2 squared plus 2 plus 2. So negative 2 over 4 plus 2 plus 2. I guess I didn't have to do that, right? Negative 2, 4, 5, 6, 7, 8. So negative 1/4. Let me know if I made a mistake. Are we okay? All right, next, letter B. Can I do direct substitution? No, but we can do algebraic manipulation. So in the numerator, that is the difference of squares. So I'm going to write limit as x approaches 3, x minus 3, x plus 3. And on the bottom, two numbers that multiply to give you negative 6, but add up to a negative 1. Yeah. Negative 3 and positive 2. I wrote plus, but negative 3, positive 2. What's going to cancel? Yeah, the x minus 3's cancel out. Now can I do direct substitution? Now you can, and here's what you get. 3 plus 3 is 6. 3 plus 2 is 5. There's my limit. Okay. Roman numeral. Letter C. Can I do direct substitution? Is there anything I can do on that one? No, that 100% is a vertical asymptote. The easiest answer is does not exist. If you approach the same behavior from the right and the left of 2, then you can write the behavior. In this case, it's not. If you approach from the right, it looks like it's positive infinity. If I approach from the left, it looks like it's negative infinity. Can you guys tell by looking at it? No? Okay. Let me tell you how I knew. So I'm going to draw a sketch, and I'm going to put a vertical asymptote at x equals 2. And I'm going to put a horizontal asymptote at x equals 1. So here's my horizontal asymptote in a blue dashed line. And behavior. 1 over 1.
Oh,
You know what I mean? No, you're good. You're good. Ask. Are we okay with that? Okay.
Wait, what?
And behavior? 1x divided by 1x as x approaches infinity. No, you're good, miss. All right. If I already know the top, if I approach 2 from the top, that the top's going to be close to 5 all the time. So it's going to be some positive number. All you care about is it positive infinity or negative infinity? If I approach 2 from the right, I'm talking about like 2.1, 2.01, 2.001. And when I subtract 2, that's always going to be positive. Do you see that? So I know for a fact I look like this right here in black. And then if I approach 2 from the left, that's like 1.9, 1.99, 1.999. Does that make sense? 1.9 minus 2 is going to be negative, some number divided by a really, really small magnitude negative number, negative infinity. Cool? If I plug in a 0, I get negative 1.5. So I cross the x-axis, the y-axis like right there, and I probably look something like this. You have a 0 at negative 3 if you want to be accurate. And it looks like that. And it looks like that. Do you see how we did it? Yeah. Yes. If I approach from the right-hand side, I'm talking about numbers bigger than 2. 2.1, 2.01, 2.001. And the top is always going to be a number close to 5, right? So 2 plus 3, 5. So 2.1, 2.01, 2.001. When I subtract 2, it's going to be a really small positive number. 5 divided by a super small positive number, positive infinity. Hey, Greta. Does that make sense? Oh yeah, there's the all-stars, the best of the best. The best of the best of the best. They're all a bunch of nerds. Okay. All right. Are we cool? I'll make sure to delete that from YouTube because I don't want anyone to throw shade. Like, this teacher, blah, blah, blah. You know what? I'm going to leave it. YOLO. All right. Is everyone cool with that one? All right. Let's go to letter D. X approaches 2. This one does have a behavior. You can also write does not exist. But because it has a behavior, there's a better answer. What is it? Yeah, infinity.
Oh, because you're squaring it.
No, I'm approaching 2. I'm not approaching infinity. If I'm approaching infinity, it's 0. But I'm approaching 2. Okay, don't worry. I see that you guys are like looking at me like, what are you talking about, Chop? Here's x equals 2. If I approach 2 from the right, 2.1 minus 2 is a positive number, a small positive number. When I square it, it's going to be positive. So I know that I'm approaching positive infinity. By the way, I know that it's approaching either positive or negative infinity because I have, if I plug in a direct substitution 2, I have a number divided by 0. As soon as you have that, you already know you have a vertical asymptote. Cool or not cool? Okay. Well, if I had a common factor, then I would not have a number divided. I would have. If I do direct substitution, I have a number divided by 0. Automatically, I'm thinking vertical asymptote. If I approach from the left-hand side, 1.9 minus 2 is a negative, but then when I square it, it turns into a positive. Now, remember, you're getting close to 0. The denominator is. A number divided by a really, really small number gives you a huge number. So it's going to look like that. This one has a horizontal asymptote of 0. So this one's going to approach the x-axis because the denominator has the higher degree than the numerator. So when you said 0, you're probably thinking like x approaches infinity or x approaches negative infinity. So sometimes you're thinking too fast, you just got to slow down. Cool or not cool? No, they've done it before where they've asked a free response, usually one that uses L'Hopital's rule. You'll figure out what that means towards the end of the semester. And they've had both answers. Infinity, and it has a word or, does not exist. So if you feel like, I don't know, does not exist as a safe option. But infinity just tells you the behavior. All right. Ready, Gonzalez? Tell me letter E. It is. Tell me why it's 3 over 2. Perfect. This works exactly like if they were to ask you in Algebra 2, because this is the type of question they had in Algebra 2, what's the horizontal asymptote of that function? You would say the horizontal asymptote is 3 over 2, or you would say y equals, but y equals 3 over 2. Does that make sense? It's the end behavior. This one only has 1. If you approach positive infinity, 3 over 2. If you approach negative infinity, it's the same number, 3 over 2. Cool? Yes. When it approaches positive infinity or negative infinity, you do end behavior. If I approach a number, that's a horizontal asymptote for that function. If. Yeah, watch. Ready, Poyo? You see this one right here? X is approaching infinity, right? What's growing faster? The bottom, the numerator, or the denominator? The denominator because of the x squared, right? So this is going to be approaching 0. Because I'm approaching a number, they're not asking, but if they said, what's the horizontal asymptote of f of x equals 4x plus 7 over x squared minus 3x plus 5. If they ask you for the horizontal asymptote, it's 0. Right? Because that's my end behavior. How do we feel, guys? Okay. All right, we're done with those. Now we have a picture of a graph here, and we're going to answer a whole bunch of questions with that graph. I thought we had more. I guess we'll ask more in a little bit. Letter A. As x approaches infinity for this graph, what does it look like to you? It should have had an arrow over here, but that's fine. Does it look like negative 3?
Yes.
Yeah, put little arrowheads on the ends there, because it looks like... Next time I'll draw better. Letter B. As x approaches negative infinity, what does that look like? 0. It looks like 0. Can someone read the statement for letter C? Perfect. So I'm looking at negative 3, and I'm approaching from the left. If I approach negative 3 from the left, it looks like it's what behavior? Infinity. Perfect. Letter D, limit as x approaches negative 3 from the right. If I approach negative 3 from the right, what does the y values look like they're approaching? Negative infinity. Letter D, limit as x approaches 0 from the left. If I approach 0 from the left, it looks like it's approaching what y value? 0. It's approaching that hole. The y value, right? Limit as x approaches 0 from the right, it looks like it's approaching infinity. Letter F, limit as x approaches 4 from the left, it looks like it's approaching infinity. Limit as x approaches 4 from the right, it looks like it's approaching infinity. Are we getting pretty good now? Remember on day 1, you guys were like, what? But now we're pretty good. Practice makes progress, guys. All right, here we go. You're going to have to use your algebra skills now. Ready? Can I do direct substitution on letter A? No, you can't do direct substitution on any of these. You have to do something else. What do you notice about the numerator? It's not the difference, it's the sum of cubes. I'm going to put the definition up here. The sum of cubes, make sure you know this, guys, is a plus b times a squared minus ab plus b squared. And I'll go ahead and write the other one as well. The difference of cubes, a cubed minus b cubed, is a minus b, a squared plus ab plus b squared. If you were to distribute those, you'll get that. Cool or not cool? All right, here we go. I'm going to rewrite it so you guys can see what's up. Limit as x approaches negative 2. And the top, remember, that 8 is just 2 to the power 3. So I'm going to write it as x plus 2, close, open, x squared minus 2x plus 4, that's 2 squared, all over x plus 2. Is everyone okay? It works. You want to see? We'll do it in a little bit so you can see. All right. Next, what's going to cancel out? X plus 2. And now can I do direct substitution? Negative 2 squared minus 2 times a negative 2, so plus 4 plus 4. So 4, 8, 12. It looks like this limit is 12. Okay, Ramirez had a question. She's questioning the sum of cubes, if I actually know it or not. She's like, no, I know, I'm kidding. She wants to know why. So let's see if do you want to work with the number or do you want to work with the top line? It doesn't matter which one. Okay, so look at this, guys. You don't have to write any of this down. You can just listen. I'm going to go ahead and distribute. And I want to see if I really do get the sum of cubes with this. So I'm going to take this a and I'm going to multiply that a by everything on the trinomial. Cool? A times a squared, a cubed. A times ab minus a squared b. Are we still okay? A times b squared plus ab squared. I don't see any mistakes. Are we still good? All right. B times a squared. That's going to be a plus a squared b, keeping it in alphabetical order. B times minus ab, that's going to be a minus ab squared, and then b times b squared. That's going to be a plus b cubed. Now let's combine like terms. A cubed, I see an a squared b, and I see a negative, and I see a positive a squared b. Those are going to cancel. I see a positive ab squared, and I see a negative ab squared, and those are going to cancel. I actually like the word zero out, but that's fine. Cancel is fine. And notice that all you have left is a cubed plus b cubed. Yeah, you should always question stuff. Yeah, good for questioning it. You should always question. Don't just, if someone tells you the square root of 5 is 2, are you going to believe it and be like, okay, whatever you say? No, guys, no, question it. All right, here we go. Letter B. Letter B, you guys ready? You can always multiply by the conjugate, but here's what I like. We've actually had like conversations with, I've had a conversation with a professor, and then I had a conversation with high school teachers. It's always hit or miss. When I was talking, I remember having a conversation with a professor on this question, and I go, technically you can do the difference of squares all the time, because you can always subtract something and say it's a difference of squares. And he's like, well, I guess if you want to be technical about it. Do you know what I mean? Like you can always, like you don't, it doesn't have to be a perfect square. You can just say, oh, I'm subtracting two numbers. It's going to be the difference of squares. If it's perfect squares, then I guess you can say, what's up, miss? Conjugate, if I say, what's the conjugate of, like remember when you did complex numbers, 3 plus I? The conjugate of 3 plus I is 3 minus I. We're going to do the conjugate with letter C in a little bit. You'll see. All right. With letter B, you could multiply by the conjugate, but I want you to see, isn't square root of x times square root of x, x? Look, square root of x times square root of x is x. No? Isn't 2 times 2, 4? Even though x is not a quote-unquote, well, I guess it is a perfect square if you count it as square root of x times square root of x. Look, you can just do the difference of squares with the denominator. Limit as x approaches 4, leave the numerator alone. In the bottom, you're going to write square root of x minus 2, square root of x plus 2. And now, what are you going to cancel? Yeah. Now, can I do direct substitution? Yes. Limit as x approaches 4 of 1 over square root of x plus 2. I get 1 over square root of 4 is 2. 2 plus 2. So 1/4. How do we feel? All right. All right. Check it out, guys. Letter C. So let me give you a hack on when to know. Well, I would say a very high percentage. See on letter C that if you do direct substitution, you get 0 over 0. If you get 0 over 0, I don't want to say a percentage, but I'm going to say a very high percentage, you will have a limit. When you get more advanced, we'll do something called L'Hopital's rule. We're not there yet. This has a limit. So, Chav, what do you do? All right, let me tell you what to do. Whenever you have something like this, you multiply by the conjugate, because multiplying by the conjugate is like the difference of squares. Chav, what's the conjugate? You see how it says square root of x plus 16 minus 4? I'm going to write the same expression, square root of x plus 16, but instead of writing minus, I'm going to put a plus. And that's like the difference of squares. Do you kind of see that? So I'm going to go square root of x plus 16 plus 4. Now remember, I need to make sure that I multiply by 1, because I don't want, that's magic if I just do that. So I put square root of x plus 16 plus 4. Now I'm multiplying it by 1, and anytime you multiply by 1 is itself. Have you changed the value of it? No. Does that make sense to you guys? Okay, so here we go. Limit as x approaches 0. And then in the top part, the square root is like an a, and then the 4 is like a b. So do you guys see how this is like the difference of squares? Yeah. So I can just go square root times square root is x plus 16. And the negative 4 times positive 4 is minus 16. That way I don't have to do the whole FOIL thing. Are we okay with that? In the bottom, don't even bother multiplying. You can if you want, but I wouldn't bother. X parenthesis square root of x plus 16 plus 4, close. what's going to zero out in the numerator? Once the 16 zero out, what can I cancel? The x's. That you can say cancel. And now can I do direct substitution? Now you can. 1 over 0 plus 16 is 16. And what's the square root of 16? 4. And what's 4 plus 4? There it is. How do we feel? You feel okay, guys? Dime. Tell me. Dime is Spanish for tell me. I guess it could also be dime in Spanish. Are we good? Yes, ma'am. I did change positive times the negative. Oh, because it's square root times square root. The square root goes away. I keep the sign. Like, why did I not change this sign? Oh, no, I got to, because this is the inside expression inside the square root. You can't touch it. When you say conjugate, you change the sign on the outside, and you leave the inside expression the same. That's like, what's the conjugate of square root of x plus 16 minus 4, square root of x plus 16 plus 4? It's a number on the outside of the root. What the whole point is that you're trying to multiply a minus b by something that you're trying to multiply it by a plus b, which is the conjugate, because it cancels out the 16th, and you just square root of happy face times square root of happy face is just happy face. Yeah, I just square root of x plus 16 minus 4, square root of x plus 16 plus 4. Yeah, look, the whole point, don't worry, I see you, miss. I want to answer a question really quick. I want to get rid of the square root. So when I have square root times square root, the square root goes away, right? And now look, x plus 16. Now I didn't FOIL it. I could have. Plus 4 square root of x plus 16 minus 4 square root of x plus 16 minus 16. And then look, these zero out. But I know that this is a difference of squares, so I can just go right into just writing a squared minus b squared. You know what I mean? All right, Paula, what's your question?
Where did the x on the bottom?
Oh, the x on the bottom got canceled out with the x on the top. Once I zeroed... Yes, that x. But I have to zero out the 16s first. Once you zero out the 16th, you have this. X over x product square root x plus 16 plus 4. Oh, you're talking about this x? X is approaching 0. So I did direct substitution. Ask.
What is this? Like, what are we doing right now? Are we like doing unit 1?
Yeah, unit 1 of that.
Okay, so can I put unit 1 in my
Yeah,
ladder?
yes.
I've been thinking one time, I'm like, is sometimes talking to this?
Letter D. Well, it's chapter 2, but unit 1. All right, guys, ready? Letter D. Do you know, and say yes, well, I hope it's a yes. Do you know how the graph of absolute value of x over x looks like?
I know how the absolute value of x is.
Perfect. So x is approaching, like absolute value of x divided by x is always what?
Wait.
Give me a number. It's always what?
Or, yeah, 1. Or it could be negative. 1 or negative.
It could be 1 or negative 1. It depends on what the x value is. Do you guys understand that? Or
Yeah.
I'll explain it again. I'll explain it again.
Wait, does it look like this?
Y equals absolute value of x over x. If x is greater than 1, if x is greater than 0, the output is always 1. 10 divided by 10, 100 divided by 100, 1,000 divided by 1,000. Yes. If x is greater than 0, output is always 1. 10 divided by 10, 100 divided by 100, 1,000 divided by 1,000.
Hold up. That's a question. So does that graph, it doesn't look like a big X.
No, it looks like this. So let's see. If the output is, if x is less than 0, remember the numerator is always positive, right? Positive 10 divided by negative 10. Negative 1. Positive 100 divided by negative 100. Negative 1. Positive 1,000 divided by negative 1,000. Negative 1. So here's how the graph looks. Here's how the graph looks, guys. I put a hole at 1 or at 0, 1, and then I make it go forever like that. And then I go to negative 1, a hole there, and I go forever that way. You guys knew that. You guys knew that.
Okay, so
No, but now you do.
now X is less. X is less than 0, then it's -1, or if it's just less.
Well, it can never equal 0 because you can't divide. But if x is less than 0, it's negative 1.
The limit does not exist.
Does that make sense, guys? What's up, Gonzalez? Ask.
But if it's absolute value and it's less than 0, wouldn't it still be positive?
No. Look, check it out. Ready? Pick any number to the left of 0. Absolute value of negative 3 divided by negative 3. Absolute value of negative 3 is 3. And then this stays as negative, so negative 1. We're good? Okay. Pollos? Plural? All right. So what's the answer? Guys. As I approach 0 from the right, I know it's not from the right, but if I did approach from the right, it would have been 1. If I approach from the left, it would have been negative 1. Am I approaching the same value? So you're going to write what? Does not exist. Yes. Yes. What I just said? Yeah, if I were to approach x equals 0 from the right, I would approach a number 1. If I were to approach x equals 0 from the left, I would approach the y value negative 1. They don't match, so this limit does not exist. Cool? Okay. Here we go. This one looks hard. It is not. It just looks hard. Look at this big mess right there. That is factorable. So I'm going to factor it over here on the side. X minus 2 over x minus 2, x plus 1. What's going to cancel out? X minus 2's. Now that the x minus 2's is canceled out, let's rewrite it. Limit, as x approaches 2, of 3 to the power x plus sine pi x, so a little bit of pre-count, not much, x to the 4th plus 1 over x plus 1. Now that I have rewritten it, can I do direct substitution? Yes. Let's do direct substitution. 3 to the power 2, and we'll break it down a little bit, plus sine of 2 pi, right? 2 times pi? Yeah. Over 2 to the power 4th, plus 2 plus 1 is 3, so that's going to turn to a 1/3. You can actually leave it like that, but let's not. So here we go. 3 squared is 9. And then what's sine of 2 pi?
No, it's 1. Oh, no, 0.
0, guys.
I definitely was thinking cosine. I'm sorry.
I was your pre-cal teacher too. Sine is the y value at 2 pi. 2 pi is 1 full revolution, so you're at 1, 0. The x value is 1, the y value is 0, so sine of 2 pi is 0. All right, here we go. 2 to the 4th power, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And then I still have that plus 1/3. What I would do is I would turn that 16 into, what's 16 times 3? 48. I would turn that 16 into 48 over 3. So then here's what you have. 9 over 49 over 3. Keep, change, flip. 9 times 3 over 49. So it looks like my answer is 27 over 49. How do you feel? All right. Oh, we're about to get to a really fun question. Like super fun. All right. This is from the course and exam description. It's supposed to mimic an AP exam. So give it 30 seconds and see if you guys can figure this one out, guys. Go for it. Hello? I can barely hear you. Like I can hear something, but I can't really hear. Okay, I'll do attendance. I'm on it. Oh, I told them yesterday that mine's broken. So. All right, guys. No, guys. I wasn't trying to meme them or. All right.
Is that gonna be your video?
No. I'm gonna edit it out. All right, guys. Let me put a timestamp. That way I can edit the video. All right. What'd you guys get as an answer? So here we go. All right, guys, focus. So remember, there's a composite function. So really, it's saying this: limit as x approaches 1 of g of x, and whatever this limit is what we're going to put into f. So limit as x approaches 1 of g of x. Here's g. What's that limit? Perfect. Good job. So now I'm going to write limit as x approaches 2 of f of x. So what's that? 3. Do you see it?
I wonder if like these 9% like truly like.
You truly knew it? So how many of them were guesses? All right, here we go. Ready for this one? You're going to need a little bit of pre-cal. Relax. It says f of x equals cosine x and c equals pi over 6. Determine whether the limit as h approaches 0 of f of c plus h minus f of c over h exists and give the value if the limit does not exist. Okay, so what do they want? They want this limit as h approaches 0. Did I leave enough space? I'm going to have to write small. Of f of pi over 6 plus h minus f of pi over 6 all over h. Try to write kind of small because it looks like it might be lengthy. Yes. I can't do direct substitution, you're right, but there is a limit. All right, here we go. I need to know what f of pi over 6 is. F of pi over 6 is cosine of pi over 6. Do you remember what cosine of pi over 6 is? Square root of 3 over 2. Square root of 3 over 2. Next, I need f of pi over 6 plus h. So that turns to cosine of pi over 6 plus h. So I'm going to come back over here. I'm going to write the limit as h approaches 0 of cosine pi over 6 plus h minus square root of 3 over 2 all over h. Is there something in pre-cal that I learned for me to expand cosine of pi over 6 plus h. Oh man, I wish there was something. Do you remember cosine A plus B?
Yes.
What is cosine A plus B? Plus or minus? So here on the side, I'm going to continue with this cosine pi over 6 plus h. I'm going to continue what that is. So here we go. Cosine pi over 6 cosine h minus sine pi over 6 sine h. Are we still okay? Okay. Do you remember what cosine pi over 6 is? Square root of 3 over 2 cosine h minus, and then sine of pi over 6 is 1/2 sine h. Are we still cool? All right, here we go. I'm going to write limit as h approaches 0. And I'm going to write this first, which I have it up here. It's that expression. Square root of 3 over 2 cosine h minus 1/2 sine h. Am I still okay? With the what? Oh, I still haven't gone to the denominator yet. Minus, I'm going to write the square root of 3 over 2. And all this is over h. Are we still okay? All right. I'm going to move this guy in blue. I'm going to move him right here, but there's no equal sign, so I keep the same minus. And I'm just going to slide this guy back. So I'm going to write limit as h approaches 0, square root of 3 over 2 cosine h minus square root of 3 over 2 minus 1/2 sine h all over h. Are we still cool? I'll zoom in so you guys can see. That's an h there, it just came out. Don't worry, we're almost done. Yeah, if you feel like getting up, do you guys want standing tables? Would that be better? I'm gonna ask for standing tables. All right. All right, here we go. Limit as h approaches 0. All right, guys. This that I'm circling, I'm going to factor out a square root of 3 over 2. So here I am. Square root of 3 over 2 cosine h minus 1 minus 1/2 sine h. And all this is still over h. Are you seeing something very familiar?
Yes.
What's up? I factor out a square root of 3 over 2. Ask.
Oh my god.
Are we still okay? I'm going to move the square root of 3 over 2. I'm going to split it up into two limits. Because I can do that. Right? That minus is from that minus up there. So here we go. I'm going to write the square root of 3 over 2 in the front. I'm going to write limit as h approaches 0 of cosine h minus 1 over h. I'm going to put minus. I'm going to put this half in the front. I'm going to write limit as h approaches 0 of sine h over h. And I'll try to make sure that no one's confused here. I just used the properties that we learned last week. I was multiplying by a constant. I just put it to the front. Are we okay? All right. Does this look like a limit that we should know?
Yes.
Do you remember what that limit is? Okay, look at your notes. It's on notes 2. It's a special limit. If not 1.
Oh, is it 0? Okay. Wouldn't it be 1 minus 1?
It doesn't matter if it's 1 minus cosine or cosine minus 1. But further out, what is it? So here it is, guys. All this right here is 0. And then look at this one. This one says sine h over h as h approaches 0. That one is what? 1. Yeah. Yes. I'm not done with it, miss. I see I've got more room. So I have square root of 3 over 2 times 0 minus 1/2 times 1. So what's my answer? Negative 1/2. Yes. The circle, the sine h over h, that's the limit property. That's 1. That's also a limit property. That one is 0. It doesn't matter how it looks. 1 minus cosine x over x or cosine x minus 1 over x. I think I put alternate forms in there. All right. Do you remember, guys, you're going to have this question in the UH quiz, and you're going to need to know the cosine and the sine. So make sure that you know your composite argument properties for cosine and sine. You can also watch the video. I think the video, I put a sine one in there. So I put a cosine on this one on purpose. Are we cool here? Okay. All right. This is called the AP. All right. Let's go back to easy questions, guys. All right. Don't worry, we're back to easy. Here we go. Yes. Oh, okay. All right, here we go. Back to easy, guys. We're almost done. Last page. What is the value as x approaches 1 from the left? Which one am I looking at? Top or bottom? The top, because these values are to the left of 1. Does that make sense? Do direct substitution. What is 2 minus 1? There it is. I'm looking to the left of 1. You look at the top equation, direct substitution. You guys ready for the next one? All right. What is the value as x approaches 1 from the right? Which one am I looking at? The bottom one, because those are x values larger than 1. What is, if I plug in a 1 in there, that's a half plus 1. What is that? 3/2, 1.5. Yay or nay? Yay. Letter number 3. Now I take away the plus sign, I take away the minus sign. What's the limit as x approaches 1? Does not exist. Why? They're different y values. If you approach from the right, it's 3 over 2. If you approach from the left, it's 1. You don't approach the same y value. Cool? All right. Number 4. What is the value of f of 1? Why? Perfect. That is where x is defined. So you plug it into the top equation. So it's 1. How do we feel? We've done every possible question that we can give you for limits. You are now ready to do all types of limits. Almost.
You know what's good at 11:30, child?
I think I fixed it.
Okay.